In these two examples, we're going to do a real quick kind of pre-calc way of looking at these, that we're going to be talking about limits as x goes to positive infinity or negative infinity. And the fact that it's a polynomial, that's going to play a big role. Versus having a rational, we're going to have to kind of dive in a little bit deeper. So if we have a polynomial, here's the key to this, is that we have our lead term. So our highest power, we have a 3x to the fourth. And if you remember anything kind of from a college algebra pre-calc, we're looking at an end behavior that we have an even power with a positive in the front. So an even power is kind of like a quadratic. So we're going to be heading both in that direction. So our limit as x approaches infinity of this function, let me just put p of x instead of writing the whole thing. So as we go to the right, our graph is going up forever. And that is it. And then the limit as x approaches negative infinity just means we're going to the left. What's happening to the y values? They are also going up. So we also get positive infinity. So that's very nice on polynomials. It's not going to work on rationals. We have to do a little bit more math to it, but let's do the second polynomial. We got an x to the third with a negative in the front, right? So it's a 2x to the third is kind of our key. Visually, we have an odd, which is kind of like a linear with a negative. So I treat it like a negative slope. So it'd be going in that direction to the right, that direction to the left, kind of like a negative slope. So all odds I treat like a positive or negative slope. And so my limit as x approaches infinity of q of x. So as we're moving to the right, my graph is going down, so negative infinity. And then my limit as x approaches negative infinity, qx is we're going up. Right, and then the math on it is that if we're plugging in really, really large numbers and cubing it and then multiplying it by a negative, it makes it negative. And eventually those numbers are going to be so much larger than anything after this that the negative is going to outweigh whatever else is happening. So we're going to get negative values. If we plug a negative into it, cube it, we get a negative times a negative makes this positive. Eventually this part becomes irrelevant. And so the further to the left we go, the higher up we will get as well, because we get a bigger and bigger positive number. But we can take a very pre-calc college algebra look to this to kind of make this a little bit quicker. When we get to rationals, when we get to stuff where we have to talk about powers on top, powers on bottom, then we're going to have to take a little bit of a different look to it. So quick summary is we have degree plays a role. So we're looking at evens or odds. And then your leading coefficient plays a role. So if you have an even, you're going to be going up or down. It's going to be like more like a quadratic. If you have a positive, it's going to be like a positive quadratic. If you have a negative leading coefficient, then your end behavior is going to look like that. It's going to be reflected. If you have an odd and it has a positive, you're going to look like a positive slope. And if it is negative and odd, it's going to be like a negative slope. And so I just draw a quick little visual like that, and then I can very quickly connect what my end behaviors are going to become.